All right, let's go over our last new concept in our normal model unit. So here we first had two unknowns, an unknown mean and an unknown standard deviation. There was two ways you could do that. In class and on the notes, I kind of just showed it using this picture where we had this location at with 30% below it. And so that was a negative 0.52 z-score, and then the 20% above it was the 0.84 z-score. Okay. So then I equated these distances. This distance from negative 0.52 to positive 0.84 was 1.36 standard deviations wide. It was also 15 from 15 to 25 questions wide. So it's 10 questions wide. All right. And so then we had set that up. 1.36 standard deviations equals 10. And these should be context. So I should have those units in there, questions. Okay. So when we have that 10 questions wide, then our standard deviation is going to have units. So our standard deviation is going to be 7.35 questions wide. All right. So then I take one of these locations. I took the positive one with the z-score of 0.84 and the context of 25. And I set up my z-score formula right here. And then I solved for the mean. And so that mean, an average of, this question's correct? I think so, yep. 18.83 questions correct. Okay, now, if you didn't like this method with the picture, here's, how to do that with just formulas. So essentially what I'm doing is setting up an equation with this z-score and this x value. So negative 0.52 equals 15 minus the mean over the standard deviation. And so the unknown mean and unknown standard deviation. The second location has this equation. 0.84 was the z-score equals 25 minus the mean over the standard deviation. Okay, then I'm going to multiply by standard deviation, and I get what I have over here with these two equations located here. So negative 0.52 standard deviations equals 15 minus the mean, and then there was the other one. Now, look, I showed in a different color going in here, and I'm going to use the elimination method. So I'm going to easily eliminate the mean if I switch the signs of this top row. So switching the signs of the items, the pieces of data in the top row, the statistics in the top row, then I'm going to combine them together, and that's 1.36 standard deviations equals 10. Okay, so that brings us back to basically what we had up here, where we set those two distances equal. So either way is fine. You don't have to do it with this picture. If you don't have the picture, you would have to show standard deviation or the z-score formulas. Okay, work has to be shown in one way or the other. All right, so I'm not going to go over in depth this one here, but we had, was this the bottom 20%? Yeah, the bottom 20% was $25 in sales. The top 15% was $350 or more in sales. Okay, so that's how I got those pictures. That set up 1.88 standard deviations wide equals 325. Divide by your 1.88, and that's how you get your standard deviation. And these would be dollars. Okay, and so then here was this item here. I don't know how that showed up. And so there we have our values that we get for the mean. 170.22 is the mean, and those are dollars. And then the standard deviation is actually larger than the mean, so that's interesting. $172. So that just sounds really big. But that looks right when I do that dividing. So anyway, Okay, so there we go. All right, next, moving on. Okay, so this kind of start mixed up the problems of ones like we have seen in the past. So now, in order to give an indication, okay, of the reason to know about this 40,000, you've got to show some kind of statistical information of where you're coming up with this stuff. So you need to probably actually do this z-score formula so you can say that that 40,000 miles is more than 3 standard deviations above the mean. In fact, it's 3.2 standard deviations above the mean. You can't just make the statement saying it's more than 3 standard deviations. You got to show support for everything. So you really needed that formula there. So yeah, that's unusual. That's an extreme outlier. Okay, so here we go. Here is our X value, and we want to go less than that. So there was our 30,000 mile X value. I then have a Z score, and then I norm CDF'd lower than that. Next up, getting the IQR. So, getting the IQR takes 3 parts. Find Q1, find Q3, and then subtract to get IQR. So remember that with Q1, that is at the 25th percentile. So Q1 is going to have always a z-score of that inverse norm of 0.25 is the z at that spot, and that is negative 0.67. Q3 is always going to have that positive version of that z-score, and it's 0.67. Once I get those values, those are miles, okay? So then I subtracted, and I got my IQR miles here. So that's all it actually asked for was the IQR. I guess that's why I didn't put units on the intermediary steps. All right, next. Here we have what proportion of kindergarten children. So I know that I'm going to be um, needing to do norm CDF to find an area. Okay, so what proportion of kindergarten children should the company expect to be less than 3 feet tall? Well, since all these measurements were in terms of inches, then I'm going to turn 3 feet into 36 inches. And so that's what I did here. And then I got my z-score. You show that z-score, and then you do norm CDF, the area below, less than 3 feet tall. Okay, it's just 11.12% of kindergarten children are shorter than 3 feet tall. Of the middle 80%, so we are going to need 2 measurements. We're going to have a lower z-score and an upper z-score, which will then equate to a lower x value and a upper x value. The lower z-score is the inverse norm 0.10, and then the others positive 1.28. Set up 2 equations to find your lower x and your upper x. Okay, IQR. So again, it will take your 3 steps. First, find your Q1 using a z-score of negative 0.67. Then find your Q3 using your z-score of positive 0.67. Then subtract to get your IQR, so that middle 50% of heights for children are between 36.99 inches and 39.41 inches. Oh, and that makes the IQR 2.42 inches wide. Is that everything? That is. Okay. And so then we are done with the main part of the learning for this unit. Okay. So now it's just kind of practice, 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 see things in different formats, and get used to just being able to understand all those different situations so that you can find the information you need to from that normal model. All right. Hope that helped.